let's do a C3 paper. This is the Edexcel C3 specimen paper. So let's start. Now the first question falls under functions. Now functions is a topic which will have domain and range, and it will have inverse function and composite function. So let's get started. We have a function which is the modulus of a function, and what we have to do is solve that function. So absolute value of x minus 2 minus 3 is equals to 1. So fx equals to 1, and we just put the value of fx. Now one thing about solving absolute value is we can solve it by taking first the negative and then the positive. So this is the concept of absolute values. So when you have modulus sign, modulus of function, and you have to solve it, what you have to do is you have to remember, if something is like this, absolute value of x is equals to a, it means x is equals to a and x is equals to minus a. We have to consider two separate situations. So what the absolute value does, actually it removes the negative sign. So if you write absolute value of minus 3, it will be 3, and absolute value of 3 is also 3. So the absolute value symbol, the two bar signs, actually removes the negative signs. And when we have to solve an absolute value equation, what we do, we send everything to the other side and keep the absolute value in one side, and then we take two separate situations. What if the whole thing was positive and the whole thing was negative? So what we can do here is, first of all we can send the 3 to the other side and write 4 here. So for, we can write x minus 2 equals to 4, therefore x equals to 6. And the next thing that we can do, for x minus 2 equals to minus 4, and this would be x equals to minus 2. So when we solve this, the answer is going to be x equals to 6 or x equals to minus 2. Now it is very important to notice if there is a condition for here. Now they said solve the equation. Now we have to recheck to see whether it holds true. Now in order for this to hold true, we have to plug in the value and see whether it works. If I put 6 here, 6 minus 2 is 4, absolute value of 4 is equals to 4, it works. If I put minus 2 here, minus 2 is minus 4, absolute value of minus 4 is 4. So this is correct. We can move on to the next one. Now in the exam, I recommend that you do the sum one after the another vertically, but here for space I'm doing it here sidewise. I do not recommend that you do it like this in the exam. So the next one, we have another function. It's a quadratic function, and we have to find the range. Now a note about range: when we talk about a function and we are talking about the domain, it is the input value. So that's the domain. What value is the input value for which we have an output value? That's the domain. Any input value that gives an output value is the domain, and the output value is called the range. So when we're talking about the range of a function, we are talking about what output value is possible. Now for that, we have to think about the range of a quadratic function. There is a special rule for the range of a quadratic function. Now for a quadratic function, the range is actually if the highest value is the maximum value. So fx has to be less than or equal to the maximum value, that is the y coordinate of the turning point. And if the y coordinate, if it is a minimum value, then it would be fx is greater than or equals to the minimum value. So whenever we are talking about range, we are actually talking about what is the value that is possible. Now here, if you take a look at the picture, so if a picture is like that, so this is the maximum value. Maximum value is usually the y coordinate. If a turning point has x coordinate and y coordinate, the x coordinate is called the line of symmetry and the y coordinate is called the maximum. In this case the turning point is maximum, so I'm calling it maximum value. Here it would be minimum, so it is minimum value here. So when we talk about maximum value, minimum value, we are talking about the range of a function, because the function, this fx, this entire picture y equals to fx, this cannot go higher than this maximum value. So the function, we know what the value is going to be. It is going to be this one or less than this one. So this is very, very important that you remember that. So getting back here, for solving this particular sum, what we need to do is we need to know what is the maximum value, what is the turning point. So let's express gx as a complete square as we do in C1. So when we do this, a square minus 2ab plus b square, b is now 2 square, so I just cancel this off, minus 2 square plus 11. So this is going to be a minus b whole square, so a minus b whole squared, so we have minus 2 square is minus 4 plus 11, so this is going to be x minus 2 whole squared plus 7. So from here we can know that the turning point is 2, 7. So this is the rule from C1. Let me do a little bit of a C1 review here. A little bit of C1 review. So in C1, so what we do is that when we have any expression written like this, px minus q whole square plus r, so what we do, the turning point is going to be, the y coordinate of the turning point is going to be the same whatever is outside the whole square, the complete square, added or subtracted, but the x coordinate of the turning point is going to be different. If this is x minus q whole squared, if it is minus q, this would be plus q, so it will be different, the opposite sign, but the y coordinate will be same. So here we know the y coordinate for this particular sum is going to be 7 and the x coordinate is going to be 2. So if you want to see what does it look like, so it will look like something like this. So it will, turning point would be x is 2 and y is 7, and it will be, since it is plus x square, it will be smile, a minimum turning point, so it will be like this, y is 7, 2, 7. So it doesn't cut the x-axis, so this is what the turning point is going to be. So now when they are talking about the range, you remember the rule, it has to be fx is greater than or equal to the minimum point, the minimum value. So here the minimum value is 7, the y coordinate is called the minimum value, so the sum is going to be range gx, because the function is called gx here, is greater than or equals to 7. So that's the range in this particular sum. Now for question number C, we have to find gf minus 1. Let me do here number C. So gf minus 1. Now before gf minus 1, it means we have to put f minus 1 inside of g. So in order to do that, what we need to know, we need to find the value of f minus 1. So this is absolute value of x minus 2 minus 3. So for f minus 1 equals to absolute value of x minus 2, x is minus 1, minus 2, minus 2. So this would be absolute value of minus 3, minus 2. Absolute value, when you remove it, it becomes positive, so this will be 3, minus 2, this would be 1. Let me double check what it is going to be. It is absolute value of x minus 2 minus 3, so let me correct it. This will be minus 3. So this will be actually 0. So f minus 1 has a value of 0. So we have to find the value of g of f minus 1. Hence, it would be g of f minus 1. F minus 1 is 0. So g of 0. And the expression is x squared minus 4x plus 11. So 0, 0, it will be only 11. So it will be 0 squared minus 4 0 plus 11 equals to 11. So g of f minus 1 is g of 0, which is 11. Let's move on to the next one. So this is numerical methods. So this particular sum falls under numerical method, and numerical method has a specific structure. So let me review numerical method a little bit. Numerical method. Well, numerical methods, there are actually a number of methods. It's methods for finding the root of an equation. So that's a numerical method. So the name of the topic is numerical methods. There are quite a number of numerical methods finding the roots of equations that are not easily found. And in this particular syllabus for C3, the numerical method that we use, it's called the iteration numerical method. It is called the iteration method. In the other papers, FP1, FP2, FP1 particularly, we have other numerical methods like interval bisection method, linear interpolation method of root finding, and also Newton-Raphson method. So that's the different type of numerical methods that we have in the higher papers as well. So here the structure of the question is, the first question you have to, before you're actually finding the root itself when you solve an equation. Now first of all, fx, this is just an expression, this is not the equation. Fx equals to 0, this is the equation. You have to be very clear about that. So fx equal to 0 is the equation, and the first thing they're saying that there is a root. When you solve this and find the unknown value of x, that's called the root. The value of x, they don't know what it is, that they're just giving you an idea. It has to be between 2 and 3. So this is what it means. Graphically it means, if you have a picture y equals to fx, and if you draw the picture, suppose the picture looks like this. So graphically this is the root. Fx equals to 0 means where it cuts the x-axis. Remember, at the x-axis y equal to 0. So if you write fx equals to 0 as the equation, that means at x-axis y equals to 0. So that's the equation that you have to solve, and this is where it cuts. So from graphically, finding the root of an equation is actually looking at the picture and finding out where it cuts. So if they mention that show that the root lies in that interval, that is step 1. You're actually not finding the root, you're actually trying to find out where the root might be. So in this particular sum, they're saying the root might be between 2 and 3. Now if you suppose the root is between a and b, so suppose the interval is a and b, and by the way the interval is like this, to show that x is the root lies between a and b, it is expressed as a comma b. Now this does not refer to a point, as we know in coordinate geometry, in Cartesian coordinate system. This means the x coordinate and this means the y coordinate, but not here. In numerical method, this and this means the same thing. It means the root is between a and b. Now if it is written like this, where a and b themselves are included, we write it with a third bracket, a comma b. So when we write it like this, it means root is between a and b, but root can also be either a or b. That's what it means. So let's get back to the main sum. And one thing I must mention is, if you notice carefully, you will see the root will only be between here if at one value the picture is below and at another value the picture is above. Meaning, if here y has a negative value, I should rather say fx has a negative value, and here the y coordinate has a positive value, so here negative, here positive, it means it is going from one below the x-axis to above the x-axis, meaning it is actually cutting. And that physical cutting at the x-axis, it is graphically the root, which is algebraically the root. In graphically, it is actually a point where it cuts somewhere. So this is important that you remember it. So getting back, the first thing that we have to do to show that for this equation there is a root in that interval, so whatever is equal to 0, so x cubed minus 2x minus 5 is equal to 0, put the value of the two values. So f2 equals to what? It is going to be 2 cubed minus 2 into 2 minus 5. it'll be 8 minus 4, 4, 4 minus 5 is minus 1, and then put the next one, f3 is 3 cubed. It's a good idea to do at least the basic calculations in your head, because that will speed up the calculation. Actually, the calculator slows down the calculation. This is 27 minus 6 is 21, 21 minus 5 is 16. Let me double check on this one. 27 minus 6 minus 5 equals to 16. That is correct. So there is a sign change. This is negative, meaning it is from below. The value of y, value of fx is below, negative, below the x-axis, and the next one at 3, it is above the x-axis. So there is a cut at the x-axis, so there is going to be a root in the interval. So we write it like this: since the sign gn changes, there is a root in 2, 3. So the next one is the actual finding of the root, which is known as the iteration formula. So we actually have to find the root. Now, iteration formula, when you find the root, you cannot just get the root. You have to go one step closer, and you actually find the root. So this x1, x2, this is actually a subscript, x base 1, x1, x2, x3, x4. It doesn't mean that we have 4 separate roots. It just means that we are actually looking for a root, and we are step by step getting closer and closer and closer. That's what it means. Now, by looking at this equation is relatively easy for us to understand that fx equal to 0, it's a cubic equation. That means it can have 3 roots maximum. A cubic equation means it can have a maximum of 3 roots. So we know it will have 3 roots, but we are not talking about all the roots. We are talking about only one of the roots, which will lie between 2 and 3. So that's what we are talking about. Now, this formula is the iterative formula, and we are using the iteration method, where we go one step by step closer, and that's what they're telling us. So the first thing to do here for finding the root is to write out this direct formula. If you notice, this is the iteration formula, meaning this is the root. If you look at the original equation, this is the equation, this is just the expression, this is the equation, and this has been rearranged in such a way that the root has been found, x. Oftentimes it is asked to prove the iteration formula. In this case, that's not the question. So the first thing to do is learning how to write this in the calculator. Now, this is extremely important. The first thing that you do, you have to understand how the calculator works. So we have to use the bracket first. We have to use the square root first, then we give the bracket. Now we have 2 plus, now this is 5 divided by x, so we can write 5 by x. Now x is written in pink here. Whatever is pink, if you want to access it, you have to press the alpha button, and you press this, you'll get this pink portion. So we have this, so bracket close, that means square root of this entire thing inside. So this corresponds to this. If you press the calc button, that means the calculator has loaded the entire equation into the memory, and you have to put the value of x. Now n plus 1 here at the subscript, at the base, n plus 1 means the next value of x, n means the previous value. So x naught, that is naught naught, x naught is 2. So if you put x naught here, you'll get x1, the next value. That is iteration. Iteration means if you want to find some value, you need the previous value. If you want to find x2, you need the previous one, n, which is x1. If you need x3, this would be x2. If you need x4, you need x3. That is how it works. That's iteration, a connection. So this actually comes from the concept of C1, which is recursion series, where for one value you need another value. So this is how it goes. So we have written it. So for finding x1, I have to input x naught, which is 2. So I'm putting here 2. When you have x question mark, you just put 2 here, you write equal to, and this is the value, so 2.121320. so this is the value of x1. Now one important note about being careful is that you have to remember the answer has to be in 4 significant figure, but you cannot write it now. When you restate it, you can write it. Now you have to write down the answer at least 5 decimal places. That's the standard, so that you can later on convert to the answer, because this is the actual answer. So 2.121320 x1 2.121320. That's it, no steps, nothing, just directly do it in the calculator and write it down. So the next one, now remember, once I press the equal to sign, the calculator by default stores that answer 2.121320 here. It has been stored by default. So we now have the value of x1 stored in the calculator here as answer. So if you press the calc button again, you have this question mark. That means the calculator is ready to load the value of x into this equation again. Now for x2 you need x1. x1 is a huge value that you don't have to write down. You can just press this button, answer, because whenever you press answer, which we did previously, it is stored here. Now let's press the equal to sign. So this is x2 2.087348. Let me check. 2.087348. so this is x2. Again, remember, the moment I press this, it has been stored in the calculator, so it is actually stored here. Now I want to take in the next value, which is x3. Let me press calc again. So the calculator is now ready to take another value of x. So I want to input x2. So let me press answer equals to, it will be 2.096517. x3 2.09, I absolutely forgot it, 6517. This is x3. Now finally we have to find x4. Now one thing you have to notice, gradually we are getting 2 point something, 2.08, it's getting closer and closer, and you see it is between 2 and 3, and we are step by step getting a more accurate answer. Now you might ask the question, when do we stop? When do you know how accurate it is? Well, most of the time they will tell you they want x4 or something, but if they do not mention x1, x2, x3, x4 and they just tell you find the root, you just stop when 2 values matches. For example, if it was 2 decimal places, 2.08, for 7 it will become 9, 2.09, and this is also 2.09 will become 10 because of 6, so they don't match exactly. So you keep on writing till 2 corresponding value absolutely matches each other, only then you can stop. But most of the time they will tell you up to what value of x they want. So x4, so for x4, calc again, you press the answer, which is x3, and it is 2.094017. so 2.094017. so now we have to write down the answer. Let me write it here. So 4 significant figure, x1, 4 significant figure. A note about approximations, it means you just count 4 digits, 1 2 3 4. It would be 2.1213. 4 decimal places, 3 won't be there. 4 decimal places would be, you take everything after one, after this decimal you have to take 4 places, that is 4 decimal places. But for significant figure means you take all the figures, 1 2 3 4, so it will be 2.121. x2 is going to be 2.087. so because of 3, the 7 will not be increased. Then x3 is going to be 2.097. so 2.096 will become 7 because of 5. If anything is larger than 4, the next one increases by 1. So this is 4 decimal digit, 4 significant figures, 1 2 3 4. The next one, x4, is 2.094. so 2.094. so this is how it works. The final one, question number C. Prove that the answer, the root, actually they're actually giving us the root 2.0946. this is the root, this is accurate. We have to prove that this is actually the root. If you check 2.094 something, so if we moved more steps, this would actually be our root as well. So what we have to do for proving this, we do not need the iteration formula. Remember, we don't need this. This is for actually finding the root. This particular sum goes back to the first question, where we have to show that the answer is at an interval. Remember, the first question was show that the answer is this interval between 2 and 3. Now the interval has to be much tighter, and we have to make this sum all over again. We have to do this sum all over again, but show that the answer is at a tighter interval. For that, what we have to do is we have to check the interval like this. So let's make this 2.0946. Now if you want to make an interval, put a 0 here. So the last thing becomes 60. So one interval would be here and the other interval would be here. So what you do is you subtract 5 from the last two digit is 60, right? So it was 6, you add a 0, you give a 0 and make it 60. If you add 5, it will become 65. So 2.09465. If you subtract 5, it would become 2.09455. So that's what's going to happen. So this is our extremely tight interval. So you see, if this thing changes sign like this, one negative another positive, it means this is a really accurate root. So we have to show that the sign changes here as well. Remember, this is not a root finding question anymore. It is not a numerical method. We have already found the root step by step. We have to now show that this is actually the root. So we have to do the interval sign again, where the interval is extremely tight interval. So it is going to be f 2.09455, and we have to do f 2.09465. so we have to find the two values from the original equation that we have, and if the sign changes, we can write, since the sign changes, the root lies in the interval. So that's what we have to do. So let's do the calculation. So since this is the original equation, fx equal to 0 is the original equation, and we have to put it in fx. So let me actually write this down as an equation. It will be easier. So x cubed. So x cubed. So this is the cube button. For the shift, you have to press shift button for the orange colored. So x cubed minus twice x. If you write 2x, it is understood that 2 is multiplied with x, and minus 5. So press the calc button. So the first input is going to be 2.094. so last if it is 60, so if you write 55 from 60, if you subtract 5, it will be 55. So 2.09455. so this is a negative value. So if you notice here, this is into 10 to the power minus 5. So it's actually minus 1.6. It doesn't have to be accurate because this value means nothing. We are just interested whether it is negative or positive. So don't bother about this too much, but this is important. Into 10 to the power minus 5. This is a power of 10 in standard form. So minus 1.65 into 10 to the power minus 5. So this is minus 1.65 into, let me clear this off so that I can write it here. Okay, minus 1.65 into 10 to the power minus 5. So this is negative. Now let's put in the next value, calc. This time we want to put 2.094. 2.094. Instead of 6, we write 65. We add 5 to it. So we write equal to, this is 1.0996. So we can write 1.1 to be very simple, into 10 to the power minus 3. 1.1 1.1 into 10 to the power minus 3. Now remember, if the power of 10 is minus 5, it means just divided by 10 to the power 5. It doesn't really affect the sign. We are not, the power of 10 itself does not really change the sign here. The main thing is this. So this is negative, this is positive. So we can write, since the sign changes, so we can write that, prove that to 5 significant figure alpha is this. So since the sign changes, you can say alpha is 2.0946. That's it.